Hi, my name is Baptiste. Today we are going to take a look at two new features developed by Stately team, type generation and the visual editor. Type generation is an improvement to TypeScript possibilities enabled in a XState machine. Thanks to type generation, we can type more strictly the events, the actions, etc. The visual editor is a new way to modify create states in a state machines. I built a really simple to-do list application with XState and React. When we first load the page, to-do lists will be fetched from the server. Today we are going to focus only on the front-end part, so the fetching is actually faked. So the list is absolutely static. We can check and uncheck to-dos, and we can create to-dos. Today we are going to do two things. The first of them is refactoring the state machine that powers this application to use type generation. Secondly, we are going to add a new feature by using the visual editor. So currently, when we check or uncheck a to-do, the mutation occurs only in the front end. Today, we are not going to code the backend code to persist those changes, but we will start by simulating the mutation. So when we check or uncheck a to-do, we want the state machine to go to an uploading state and to be prepared to send those operations to a server. All the application is powered by a XState machine. So we can open the inspector to see it globally. So to-dos is our state machine. The first state is fetching to-dos. When we fetch the initial to-dos, we then go to idle state. In idle state, we are waiting for two things to happen. Either the user wants to create a to-do, or the user updates the status of a to-do. If the user wants to create a to-do, that is, if the user clicks on add a to-do button, we want to enter in this form. So, thanks to create to-do event, we go to creating to-do state. And in this state, we can receive a save to-do event or either a close to-do creation event. These events are triggered by save and by cancelled buttons, but you can also press enter. What are the problems that solve the type generation? So, in fetching to-do state, we invoke a service which is a promise. So, it doesn't fetch data from server, but instead it simulates it. So, it waits for 1 second and then returns a static list of to-dos. The return value of this promise is to-do item array. So we would expect in a return transition to get the event as a done invoke event to-do item array. But instead, in the current version of XState, this event cannot be typed correctly. So if I remove the type annotation, it says that event is of type don't invoke event any. So the property data can be anything. So to get more TypeScript here, we had to add the annotation. This is something that the type generation solves. Another thing that the type generation solves is tags and states. If I go to my view, you can see here that I use state.matches and state.hasTag. Currently, hasTag takes a tag which is of type string, so we can even type a tag that is not declared in the state machine. Type generation solves this issue because it will determine all the tags of the machine and it will narrow the tags you can put in hasTag call. And it does the same for matches. It knows what are the possible states in your machine, so it will restrict the states you can put. This is really great for type safety. One great thing that I don't have in this type machine, but that is really great, is that entry actions and exit actions can be typed correctly. So in the previous version, event could be anything, because XState could not know the event that triggered a transition to creating to-do state. But us, we know that there is only one thing that triggers a transition to creating to-do state. It's a create to-do event. Thanks to type generation, XState will know that this event can only be of create to-do type. This is amazing. Finally, one recommendation that is more important than ever is to use named action, named services. It's to replace inline implementations by a string that represents what is going to be done. So in this case, we receive a save to do event which contains the new to do. We want to append the new to do to the to do's list. We were using inline implementation to get correct types for events. So in my case, XState knows that to do property exists on the event object because it knows that it is used in response to a save to do. And therefore, we were not using too much named actions, because if we were using save assign to do to context and we were declaring the action in the second object based to create machines, XState would not know what is the correct event that triggers this transition. So I take back this implementation, and as you can see, to do is not typed. So what we had to do was using a type assertion to ensure that event type was of type save to do, and if it was not the case, we were raising an error. So this is what we had to do, but thanks to type generation, again, the state machine will know that assign to do to context action is called only in response to a save to do event, and therefore we will be able to remove the type assertion and event will be necessarily of type save to do. This is amazing. And one more thing is that the visual editor can only operate on strings like that. So the visual editor does not care of the implementation behind the name, and it cannot it cannot load a state machine that has an inline implementation. That's why we get this warning from XState extension. Now let's code. The first thing to do is to upgrade XState dependency. So we want to use a new version, which is 4.29.0, and we want also to ensure that we are using the latest version of XState React. Without that, we won't be able to use machine hook with our new machine. So yes, XState and XState React. And the other thing is to ensure that you are using the latest version of XState VS Code extension from Stately. Be sure that you are using this version from Stately. Okay, so the first thing to do to enable type generation is to use TS types so don't forget to install your dependencies, and then the first thing to do to enable type generation is to go to create machine call and write TS types. So give it an empty object, and you will see this thing that appears immediately. The extension has created a todo machines typegen file next to your machine. This is the type generation. So this is what will tell XState more information about the state machine. Let's take a look. So we can see property internal events, and property of this object is done invoke to-dos, fetching to-dos, invocation 0. What it means is that when our service will be done, this event will be triggered by the state machine. We will never write such an event, but XState use them and understand them. As I said, states are now typed correctly. As I said, so we can see that there is a matches states property. It's a type union of all the possible states in the machine, and it's the same for tags. I have only one tag, so we can see it. If we go to our view, we can see that we can only provide one of these three states to state.matches. If I try to write something wrong, a state that does not exist, TypeScript tells me that it's not possible to do that. And it works the same for tags. This is a really huge improvement because it was really easy to misspell a state or a tag. Now it's not even possible. So the first thing to do is to use named services and named actions. We want to benefit from type generation fully. So we replace this inline implementation for our service that fetches the initial to-dos by fetch to-dos service, thanks to GitHub Copilot that helps me there. Then we go to the the end of our state machine, and we provide the config object with services fetch to-dos, which is the service we just copied. Nice. So the next thing to do is to define a schema. The schema is where we are going to tell what our services can return. So we want to say that fetch to-dos service let me check the documentation. Yes, so services, my service. Okay, so let's add that. Services is an empty object that we cast to fetch to-dos data. We type data from the internal event sent by XState to itself, and data in our case is an array of to-do item. So perfect. Thanks to that, if we go to undone transition, we should be able to remove this annotation. And no, it does not work. So we want to replace this action by assign initial to-dos to context action. So we go to the config object, and there, as well as services objects, we provide assign initial to-dos to context. And now event is typed correctly. So one thing to note is that for type generation to work properly, we need to use named services, named actions. I think we should do that anywhere. So now we must use actions services. So now we must provide only names for actions, services, etc., and define the implementation later. We can do the same for other actions. So save to do, we replace with assign new to do to context. We create the implementation, and yes, one thing to note is that we will get auto-completion because the type generation will know which actions we declared in the state machine, which services, which guard, and therefore let me just paste it. If we want to write an action that is not defined in the state machine, TypeScript will tell us that it's not possible. And then we want to do the same thing for the last action. So update to the status. We tell update to the status. Okay. And here, update to the status. So nice. And as you can see, why is to do not typed correctly? And if I try to remove todo model, yes, okay, so createModel. So if I go to the top of my file, I'm using createModel API. This API is deprecated. You can still use it, but in the future it will be totally replaced by type generation. Type generation does what createModel tried to solve way better. So you can totally replace createModel with type generation. And in our case, we must stop using todo model for type generation to work properly. So now checked is a boolean, todo to update ID is a string, and we are good. So we did the first step, that is replacing inline implementations with strings. And thanks to these strings, the type generation can work properly. So new things appeared in todo's machine type gen file. We can see events causing actions. So it means that update to status, assign initial todos to context, etc. These are actions we defined in our state machines. And these actions can be triggered by these events. Update to the status can be triggered only by update to the status event. Assign new todo to context is triggered by save todo. And assign initial todos to context can be triggered only when the service, the fetching service, is done. So when we declare update to the status here, the state machine knows that yes, here, update to the status. So here, the state machine knows that the event is necessarily of type update to the status. But if this action was called in response to another transition, for example, if I try to do that, when we close to the creation, we call this action. It's totally it has no sense to do that, but it's just to try to see if types are updated correctly. And as we can see, update to the status can now be called in response to either update to the status or close to the creation. And the consequence in the declaration of this action is that ID property does not exist, because it exists only in update to the status event, not in close to the creation event. So I think we can say that now we are type saved, and this is really, really great. As we saw, using createModel with type generation is not the best idea. We can replace createModel with type generation totally. This is what we'll do now. So, the first thing to do is to create a type context. If you were using XState prior to createModel, I think you did that several times. So, let's create type context. It's only type. We will have to provide the default value of the context later in the state machine. But now we only create types. We also create event type, which can be create to do, or yes, or close to do creation. And I think that GitHub Copilot is going to complete the rest. Yes, Nice. So let's save. Yes, there is an error here. Let's save. Do I have all my events? Create to do, close to do, save to do, which is not a to do item but a string, and update to do status with an ID and a checked parameter. So now we want to use context and event in the state machine. So we will replace todo model.createMachine by createMachine imported from XState. Here. We will continue to add more information to the schema of the machine. So we have a context, and we do the same as for services. We use an empty object and we cast it to the type we defined. In this case, it's context, and we do the same for events. An empty object as events. We want to provide the context, the default value of the context. So we grab that from createModel call, and here we do and we will now deactivate totally the createModel. Sorry, that. Okay, so save, and to-dos is typed correctly. That's great. So let's remove this. Let's remove that. Nice. Okay. So let's see if we broke something. We go to the application, and it seems to work. We can check, we can uncheck, we can create a to-do. Okay, nice. It works. That's great. So we totally replaced createModel with a simple create machine, but we got a lot more from type generation than from createModel. So everything we could do with createModel is now possible with the type generation, and even more. So we can even remove don't invoke event, and that's great. I just want to check something. So where do we use machine? Here. Let's see what happens if I don't provide an action. For example, update to do status action. Yes, one really cool thing just happened. What is a TypeScript error? We need to provide a second argument to use machine. And what's the problem now? Property actions is missing in type empty object, but required in type actions. Maybe make keys required update to the status. It means that we have to define update to the status, because XState determined that we are not defining this action when we create the machine. Therefore, we must provide an implementation when we want to use a machine. It's amazing, simply. So we don't want to do that here, but it can be really useful if you have a service, an action that must use a dependency, for example, in React or in Vue.js. So this is the way to do that. You can simply ignore the definition of the service of the action in the machine, but you must provide it when you call the machine with use interpret, use machine, etc. And now the error disappears. We are done with using type generation. I hope that you liked it as I do, because I find it really amazing. It solves so much headache we could have in the past. Okay, now that we have seen how to use type generation to type more strictly our state machines, let's take a look at the visual editor. So, the visual editor loads our state machine and tries to place our states and our events. What is really cool is that we can move those things, and if we close the editor and reopen it, we are going to see that states and events will be at the same place. This is because all the moves are stored in this really long code, and XState extension will load this code when the visual editor loads. So you can share your state machine, you can move your states, your events, and everybody will see the same state machine in the same state. So let's take some time to move states around. Okay, so fetching to-dos, yes, I want it on the left, idle on the middle, creating to-do, I want it on the right. And when we are done with fetching to-dos, we go to idle. When we want to create a to-do, we go to creating to-do. We can close the creation form, and then we can save the to-do. Nice. So what is really cool with the editor is that it's you who choose how to place the states and the events. When you use the visualizer and not the editor, the extension uses auto layout. It means that you can't choose how to place states and events. It's automatically decided for you. But it can be problematic because where states and events are on the map can give some meaning. For example, putting creating to-do on the right and fetching to-do on the top left means that fetching to-do is really the first state, idle is on the middle, it's a central place, so you will mostly be on idle state, and it really gives some meaning in addition to your states and on events. So yes, it gives some meaning. Okay, so let's see what happened to the state machine itself. We can save the file. So firstly, the transitions have been modified, and now they all begin with hashtag to-dos. Hashtag to-dos refers to the ID of the machine. That way, all transitions are made really explicit. You are sure that idle is the first child which is named idle of the machine to-dos. What can we see? Okay, I think that's it. Yeah, another thing, we can see that onDown is now an array. You might have not noticed, but previously it was just an object, and the visual editor modified it. So let's check another feature of the visual editor. Let's create a new state. So let's create a state here named some state. Okay, so as we see, some state has appeared in the visual editor. The visual editor and the state machine in the file are really synced. Everything that happens in one will happen on the other one. Okay, let's remove these states and let's begin with creating the feature we want. So I go back to the previous state. Perfect. Okay, so to summarize, what we want is that when we check or we uncheck a to-do, or when we create a new to-do, we want to send the new to-do list to the server. There are several ways to do that. Today we are going to use the most straightforward way, I think. So we create a new state in to-do's machine. This state is called sending to-dos to server. So you can see that you can choose the type of the state. It can be an atomic state, a normal state, a state that has no children. It can be a parallel state, an history state, and a final state. Yes, you can even specify invocations here, as it's the case for fetching to-dos. So fetching to-dos has one invocation, fetch to-do. You can modify it. It's really cool, really. You can specify entry and exit actions. So in our case, we want to go to sending to-dos to server when we update to-do status. So instead of going to to-do state here, we want to go to sending to-dos. Okay, so nice. We'll move that here. Okay, so let's close this. Okay, so I think we will even delete this event. We'll recreate it. Or not. Can we move the source of the event? Yes, nice. So what happens is that, let's try the simulate mode. Okay, so we fetch to-dos, we go to idle. In idle we can create a to-do, and now when we are creating a to-do, we can update the to-do. We are going to sending to the server, I think. Go back to the machine to see what happens really for this event. So update to-do status. We can see this event only in creating to-do state. So when we are in creating to-do state, we receive a update to-do status. We go to sending to-dos to server. Nice. This is what we want. And we update to-do status. Nice. We want to be able to update the status of a to-do when we are in idle state too. So let's go back to edit mode. Let's click on idle. And yes, so we go to sending to-dos to server. We modify the event. It will be perfect. So events are auto-completed. That's really great. And we will call an action. So let's move this. So I want to call an action what is the action? Update. Oh, perfect. So it's really nice. Even actions are auto-completed. Let's save. Perfect. So if we go back to simulate mode, we see that first we are in fetching to-do state. We receive the initial to-dos. Now we are in idle state. In idle state, we can update the to-do. We can update the status of a to-do, and I reset. So we can also, in creating to-do state, update the status of to-do. Great. So let's define more things on sending to-dos to server. We go back to edit mode. In sending to-dos to server state, we want to invoke a service. This service will take the current context, the current to-dos list in the context, and send it to a server. So we can call it send to-dos to server. Okay. And when the invocation will be done, I want to go back to idle state. No, I think we don't want that, because, let's delete that, because if we are in creating to-do state, we want to remain in creating to-do state, and if we are in idle state, we want to remain in idle state. As a consequence, I think that creating to-dos or being in idle state can be parallel to the idea of fetching the current status of to-dos. So maybe we should design that by using parallel state. We would have two orthogonal regions, one that contains idle and creating to-do states, and another one that would be responsible of sending the to-do list to the server. Okay, so we will try to model what we want with a parallel state. So the first thing to do will be to create a new state in to-dos machine. We will call this state to-dos management. Okay, so in this state, we will say that this state is parallel and has two child states. The first one is to-dos creation, and the second one will be persistence to persist to server. So in to-dos creation, let's try to put it. No, we can't. So I will create a state here. Can I move idle state there? Don't think. So no. Let's recreate the states. So first thing, when we have fetched the initial tracks, we go to to-dos management state. So we shortcut all the other states. Now in to-dos creation state, let's zoom in. In to-dos creation state, we will create an idle state. Idle, nice. Then I think the most fast way to do that is to directly modify the code. So I will take idle state, creating to do. Perfect. Yes, nice. I take those states and I put them here. Let's save. And let's see what happens. So states idle. Okay, so the IDs, yes. Usually I don't use IDs, so I will have to update the IDs. So it will be todos management, todos creation, copy, paste. Yes, and no, for now we are going to deactivate this transition, but yes, now we should be good. What is the problem? Todos management, todos creation idle, sending todos to server. So yes, okay, same problem here. Deactivate. Nice. Okay, so we can see that the editor has been updated. Okay, I think we can delete sending todos to server for now. We will recreate it later. So in todos creation, the first state, the initial state, we can see that idle is the initial state thanks to this arrow. Okay, so we will create states in persist to server. We create an idle state here too, and when we receive oh yes, nice, very nice. Here we will sending to server. So we go to sending to server when we receive an update. Yes, we will do that. So update. How was this even called before? The event was called update to do status. Okay, so let's go back to the visual editor. Update to do status. Nice. So when we want to update the status of a to-do, we go to sending to server state. In sending to server state, we invoke a service. We invoke send to server, and when send to server is done, we go back to idle state. So what happens? Okay, let's try again. Nice, perfect. So when we update the to-do, we go to setting to server, and then we go back to idle state. Let's move states and events around. So I want save to do to be here, create to do to be there, and close to do to be with create to do. Okay, it seems nice to me. Nice, great. Okay, so to recap, when we are first, no, I want idle to be on left, so let's swap them. Okay, let's keep that for now. So first we can create a to-do. We go to creating to-do state. Then when we save the to-do, we go directly to idle state. I think there is a problem there, because what we would want to do is when we receive save to do events, we send the created to do to a server. So we will make substates in creating to do state. So okay, waiting to do creation. We create the initial state, and the initial state is waiting to do creation. Then we have a state called send to do send to do to server. When we receive send to do event, we go to send to do to server. And we assign the created to do, assign new to do to context. Nice, really nice. So I will increase the size of those things. Yes. Okay. Nice. Now we can delete this event and create a new event, a new state in creating to do state that will be called send to do to server. And this state will be a final state. So when we have sent the to do to the server, we go to send to do to server. Let's delete the event for now. Let's move that to have more place. And now we have to invoke a service in send to do to server. This service is going to send the to-do to the server. So firstly, we rename send to server to sending to do to server, and we invoke send to do to server. And when this service is done, we transition to send todo to server. Finally, when creating todo state is done, we can go back to idle state. I don't know if I can do that. Okay, so am I able to have an undone transition? No, not for now, I think. So that's not a problem. We will add the undone in the code. So let's increase the code. We save the code. So send to server. When this is done, we go to idle target, idle, and I think the editor is going to update the target. Yes, perfect, nice. So go back to the editor and let's see if this is what we want. So go to simulate mode, we fetch initial to-dos. Then let's try the inspector. Okay, so nice. We fetch initial to-dos. Then we go to to-dos management parallel state. Here we are handling update to-do status event. We send to the server the update of the status of the to-do, and then we go back to idle state. In to-dos creation orthogonal region, we handle create to-do events. Then we go to creating to-do state. We can save the to-do and then we send the to-do to the server, and when the server has received the new to-do, we go back to idle state. I think it works the way we want. We will have to, I think, update some names of service that are not really clear, and then we are going to update the services and the actions. So I go back to the visual editor. So creating to do, waiting to do creation. We save the to do, sending to do to server, send. Yes, let's rename it sending new to do to server, and the invocation is sending new to do to server. It's better. Let's try something. Let's try auto layout mode. For now, we decided to move states and events ourselves, but thanks to auto layout, we can let the system reorganize states and events for us. This is not necessarily something you might want to do every time, because, as we said, being able to move states and events to give more meaning to the machine is really nice, but for now we can use it. So then send new to server, send new to server. Let's be consistent. Nice. And now let's click on auto layout. Great. And for persist to server region, we rename the state. Updating to-dos. Update to status, sending to server. We rename this state to in sending to do update to server, and we do the same for the service, send to do update to server. We can even say to do status update. Okay, nice. Let's click on auto layout. Great. So I think we are good with the state machine. Now we have to save the file and provide the services and the actions. So okay, so the service fetch to-dos remains the same, but we have two new services to create: send new to do to server and send to do status update to server. So yes, thanks GitHub Copilot. We will try something really simple. As we don't have any server to talk with, we are just, as GitHub Copilot says, wait for a timeout. But we can see that the event is correctly typed. So yes, let's keep what GitHub Copilot said, and let's log the to-do. Nice. We create the over service. Perfect, perfect. Thanks GitHub Copilot. So what's wrong with that? Are we still using update to the status section? I don't think. This is a problem because we want to put the update of the status in the context, and then we call the service that sends the update to the server. So we open the inspector again, the editor, sorry. So when we receive update to the status, indeed we want to call an action update what's the name of the action? Update to do assign to do status update to context. Nice. Okay, let's use auto layouts. Nice, perfect. So go back to the machine, and now we can keep the implementation, but we have to modify the name of the action. So create the state machine is good, I think. We will have to modify perhaps the view. Yes, for example, the tag has been deleted. What happens in the browser? Okay, we get the initial load, and then if we click, yes, okay, it seems that the state machine is stuck. What happens when we update the status of a to-do? So creating to-do. Okay, I see, yes. We are not going back to the idle state. So let's open the inspector again. Here, yes, that's it. So in updating to-do state, we receive an update to-do status event. We invoke send to-do status update to server, but we don't go back to idle state. If we do that and use auto layout, it should work better. Let's see. Okay. So after some time, a message is logged in the console, and no, it doesn't seem to have solved. Ah, yes, I have to save the file. Okay, let's reload. Now, okay. No, it still doesn't work. What happens? It seems that the modification has been erased. Okay, let's try again. Then auto layouts. Sorry. Okay. I want to don't focus this thing anymore, please. Yes, nice. Auto layout. Okay, so save the file. Okay. No. Yes. The transition is erased at this moment. Don't know why. That's strange. Okay, so keep the file like this. Try again. So we check, we get the message in the console, and now we can uncheck a to-do. That's great. And while a to-do is being sent to the server, we cannot interact with the to-do list anymore. Okay, and can we add to-dos? So yes, I have to update the tag in the view. We are no longer using this tag, so go back to the machine. No, let's try to add a tag in the editor. So we want to show the creation form when we are in creating to-do state. I don't think there are tags here. That's not a problem. Creating to-do. Okay. Let's add a tag here. Okay. No. Yes, really strange. The done transition is erased. So let's undo. And now if we refresh the view, we should be able to create a to-do. Yes, nice. So the form is shown, and now can we create a to-do? Yes, okay. So but I think the form should be closed, and it's not. Or not. I don't remember if this is a feature or if we introduced a bug. So let's stash the work. Let's refresh. Let's check. Okay, no. We have to close the form. I don't know what it has not been closed. I think this is because I put the tag not on the right state. So go back to the machine. Okay. And where is the tag? Sorry. Oh, yes. There. So okay, I think I think there is another issue with the undone transition. So when sending is done, we should go to send new to server. So I open the visual editor again, and this time I hope that the undone transition will not get erased. Yes. Yes, great, that's it. So go to send new to server, use auto layout, and now save the file. The undone transition here has been erased. So undo. No, that's really strange. The undone transition has been erased. Not the one we just solved, but the previous one. It's strange. So okay. Let's save. And let's add the transition ourselves. So that one, send new to server. Now let's see if it works. We can check. We can uncheck, we can open the creation form, and we can send the to-do or not. What happens? So we don't exit the state, I think. Open the inspector. Create to do. Save to do. Sending new to do to server. Strange. let's add a log action here to see if the undone transition is recalled. Okay, we try to create a to-do again, new to-do, sending new to-do to server, new to-do. So yes, one cool thing to with the editor, with the visual, with the XState extension, is that we can go to the definition of an action, a service, a guard. It's really cool. So what happens? Sending new to do to server, new to do. But we oh yes, I understand. In fact, the undone should not be on the state but on the invocation. And it's probably the same. No, it was not the same. It was not the case with update sent to the server, but here I did this mistake, so it should work probably. Okay, refresh, create a to-do, new to-do. Perfect. Okay, so everything works. We could improve the user experience by disabling the inputs and the add a to-do button while we are sending the request to the server. Let's do this quickly. So just to improve the user experience, we will cancel inputs and the add to the button while we are sending a request to the server. So let's go back to the view. This time we can close the state machine and is updating to-do status. That's really great. All the possible states have been determined by the XState extension. Therefore, we can use to improve the user experience, we will disable the inputs and add a to-do button while we are sending a request to the server that is freezing the state machine. So we go to our view, and in the state machine we will add some tags we can use in the view to know if a request is pending. So in sending new to do to server, we add a tag sending new to do to server, and in updating to do, sending to do status update to server, we add a tag to. Yes, that's not probably the best tag. we can do something even yes, we will do something else. So is sending request to server. Let's go straight forward to the point. When we send a request and are still waiting for its response, let's just have this tag, and on the UI state as tag. And again, if we misspell the tag, a TypeScript error is thrown. It's really great. So we take is sending request to server constant, and we disable the checkbox. So we take a boolean in checkbox list. So the list takes this boolean disabled. We can disable all lists, disable all lists, take it in the component, and if we want to disable all the lists, we go to each input and say disabled equal disable all list. Perfect. That's great for the checkbox. Now we take the prop, so is sending request to server. Do it for the both checkbox lists, and now we have to disable create to do form. We take disable prop, which is a boolean, take it here too, and then create to do. Yes, no, this is not there, but we want to add this this prop. So let's go back to the main view. Sorry. Okay, so okay, so that's not that. It's create to do form here. What we want is to add, yes, perfect, it's there. So show to do creation form. If it's true, we show the form. Otherwise, we show the button add a to do, and it's this button that we want to disable. So disabled equal is sending request to server. Now let's try to see if something is disabled or not. So yes, as you can see, the pointer changes. The cursor is of type pointer when the input is not disabled, but it's of type default when the input button is disabled. And as we can see, yes, it seems great to me. I hope you found the both features developed by a stately team as interesting as I do. You can learn more about type generation on Stately blog and on XState documentation about TypeScript. See you soon, probably in a next video about XState. See you and thank you.